Now we're going to turn our attention to piecewise functions graphically, and we're going to evaluate them graphically. So this is a piecewise function because there's a couple pieces to it. There's a line and then there's a random dot right here. The line is not what we use for the piecewise definition right here when x equals 1. So our job is to look down here and exactly evaluate what is f of 1. So f of 1 says for us that we look at this graph, go to the x value of 1, right here, this whole x bar, and figure out where do we have a solid dot on that line. Well, that solid dot is very well identified. It's at -4. So we could have not had any of the graph and just seen that dot there and known that the answer was 4. Essentially what you're playing with is the coordinate is 1, 4. The f of 1 is asking what's the y output here in this coordinate, the x being 1, output being 4. So now another very similar function, the whole moved for us. And you can see here the whole is when x is 3. And then they piecewise define the function for us on here to be when x is 3, we're at -6, not on this line. But everywhere else that the function is defined, it's on this line. So we are asked to evaluate f of 4. Well, don't get hung up on the fact that the last one, it was the dot answer. In this case, we're supposed to go to 4. And in our mind's eye, kind of have a vertical line happening. And we go on this vertical line to see where does the graph touch my vertical line? Well, there it touches at 6. So my output f of 4 is 6 because the coordinate 4, 6 is on that graph right there. This next piecewise defined function is more exciting. We've got a horizontal line and then another line with a slope of -1, it looks like over there. And then we are asked to evaluate f of -4. So we just focus on -4 and mentally go to a place where we're just seeing this vertical grid line. And then we are looking for the intersection of the grid line and the graph. Well, that happens right there at a y height of 6. So f of -4 is 6. We don't have to be concerned about the fact there's a hole, this empty space. None of that matters because we're just focusing right there when the x value is -4. And the output was 6. If I was asked a question like, what is f of 2? Well, 2 would be right here. And what you'll notice is that nowhere on this graph is there any definition. And what I mean by that is there's no squiggly function, there's no graph in there. Because there's nothing in there, if I was to find f of 2, since this is empty space on the graph, you actually say this is specifically undefined, because the function is not defined for any y height in that empty space. So if you've ever used the word undefined before, that's really what we're referencing, is that it's literally not defined. There's nothing there. There's no graph there. Now in this interesting function, I've got 2 holes happening. These are both holes, hole there, hole here, and then a solid dot here. We've really got a lot happening as we approach and get near to the x value of 5. Well, the fun part is we actually have to evaluate at f of 5, which is excellent for us, especially if we're moving closer to pre-calculus. What we'll notice as in the analysis we'll do in pre-calculus is we'll follow the graph and be like, as we get closer to the x value of 5 from the left, it heads down to -4. As you get closer to the x value of -5 from the right, you're tracking this line up to there, and you get a y value of -2. Those are technically limit results, but the actual f of 5 is whatever defined solid dot there is right there. And this solid dot is a y height of 2. So the fact that we are heading down to -4 or heading up to -2 doesn't matter for what is the actual output f of 5. The actual output is 2. This coordinate 5, 2 is the actual value on this graph for that function. Later you'll talk about limits, and the limit from the left, limit from the right are different. The limit overall doesn't exist, but that's pre-calculus. Here we're defined at 2 is the output we're looking for. On this last graph, we've got a lot of interesting graphs and pieces going on, especially around here at 6. You see there's a lot of definition happening as you approach left and right of 6, but then we're not even looking there. We're looking over here at -1. So the x bar of -1, this vertical line of -1, you'll notice it's got a hole there. That's the only defined space is right of 1, not on 1. So since there is no defined solid dot anywhere, they didn't put a solid dot here or put a solid dot elsewhere, we just have that hole to reference. This is the function being actually undefined. defined. So that is what you write when you have a hole or empty space, or if maybe it asked us to find f of -2 out here, and we're like, well, there's nothing over here. It would also be undefined. Anything left of 1 actually would be undefined. You could be asked anything left of 1, and the result would be undefined. Anything right of 1 is defined, though. So anything to the right of that, check that out. You got solid line here, and then even though there's a couple of holes there, it is defined there. And then this parabola says it has an arrow. So everything, literally, if I was to find the domain of this graph and ask you about that, which I might, the domain for this function is all x values bigger than 1. Anything left of 1 is undefined. So undefined for x less than or equal to 1, this graph is. But its actual domain is anything bigger than 1. So pretty cool beginning of our piecewise analysis.